In this video, you will see how to create a road corridor within the 3D Experience platform using the Civil Engineer and the Polyhedral Modeler roles with the Civil Engineering 3D Design app. In this example, we reuse the alignment generated in the previous tutorial. The Polyhedral Modeler is a new modeler that will allow you to perform design operations between the survey data, which is a mesh, and solid and surface CATIA data, which are necessary to build the corridor. To activate it, you just need to right-click on your terrain and enable it for Engineering 3D Design, and it will automatically create a new polyhedral terrain in your tree. First step here is to create a road surface, which will be the top surface of the road. By taking the 3D alignment as input, all the data such as the type of road, here a crown, the number of lanes, super elevation, will be transferred and taken into account by this surface. The automatic mode will take the super elevation definition from the alignment and from the design rules to generate the proper surface. In the by law mode, you can visualize the super elevation applied and their transition rate. Notice here that we have the 6% super elevation we changed manually in the previous tutorial. For the width, this is the same behavior. The one set by default in the alignment will be taken into account in the default mode, and you can display the laws if necessary. When I click on OK, the super elevated road surface is generated. Next operation is to create the corridor. I can either first create the subgrades, meaning the different layers of my road, and then generate the cut and fills, either compute both at the same time. The subgrades required also a 3D alignment as input. Then you can pick the typical cross-section you want to use. You can either build your own cross-sections, either use startup data available in your install. You can notice here that you have samples for excavation and fillings only, subgrades only, and the last which combines both. This is the one we will use for this example. The road surface is also required as input to get subgrades following super elevation and widening of the road. You can then define your outputs, which will be the 3D volumes of your layers, but also break lines if you need them for construction later on. You have different modes of computation: coarse, medium, and fine. Fine is the more accurate, but also the longer to generate. We pick then the polyhedral terrain that will be excavated to build the road. You can decide whether you want to compute excavation and/or fillings. Finally, you can handle the typical cross-section and adjust parameters at different locations. You can add points on the alignment to specify some change in the typical cross-section at a specific location. Finally, we compute the corridor. This will create a road stretch, and we can compute as many road stretches as necessary in case we have to change completely the typical cross-section from one spot to the other. Now, a modified terrain has been generated. We have the excavation works and can look at their volume through the basic volume command or through the beam attributes. Same for the filling works. Under the subgrade node, I get also all the different volumes for the binder, base, and subgrade layers. I can then use the section tool to visualize the cross-section of my road.